You guys have a password for the Wi-Fi here?
Yeah, it's the address, which is
415 West Gray.
415 West Gray. Perfect. We're good to go. Okay, good. We're about to get started. So let me welcome you guys to the Blockchain Artilect. You know, that's the presentation that we have for you today. And also let me, welcome you officially to the first 2016 Texas Coinitiative meetup. We're also gonna do a talk about Ethereum, later. So if you never have heard about Ethereum, we're gonna have a whole section, covering, Ethereum as a technology. Before I get started, we're gonna have this monitor right here that is gonna show us a lot of the information that I have for you guys. It's quite a bit of information, so let me just give you a little bit rundown of the layout that I have for you today. So we have the part one of the presentation. It's called the Blockchain Artilect. This is the part where we're basically going to talk about two things: education and technology. So, and then we're going to do a Q&A just in case you guys have any questions. We're going to make a little pause right there. And you're going to have a chance to, ask any questions you may have, for the next few slides. Also, after that, this one's pretty good. It's called State of Bitcoin 2016. On here, we're going to talk about the state of the network. What's going on in Bitcoin like these days. What's the, the debate that's going on. You probably have heard about the debate between Bitcoin Core and Bitcoin XT and, Bitcoin Classic. So we'll analyze, exactly what's going on, on the network. And part number three, a mathematical intro to Ethereum. That one is actually pretty good. It's very, dense because it's got a lot to do with math. But I thought it would give you a very good overview of what Ethereum is, because it's very abstract, but I'm going to try to explain it to you in such a way that we will understand Ethereum from a very fundamental level, So hopefully you will get to know a lot more about Ethereum after this presentation. Something really important here. We have a link to all this, the PDF that you're going to see. It's a lot of information. So please, if you would like to check some of the info here, you're going to have a chance to click on the link that I sent to you guys through the meetup. So you're going to have a chance to check the information later because it's quite a bit. So also let me do a little introduction about myself. My name is JJ Campuzano, and I currently head the, the education initiative here in Houston. And so right now, it's my opportunity to present this education initiative. So let's get started. What is I Am Bitcoin? This is the education platform that I want to introduce you guys today. This is the website, iambitcoin.org. It's an education platform. So it's very, simple, very, very easy for you guys to comprehend. It's just education. But what kind of education? What kind of stuff we're going to see in this, website. This is basically what the presentation is all about. So let's check it out. The first part of the course, it's called the Core Course in Bitcoin and Blockchain Technologies. So this is a course where you're going to be able to learn a lot more about Bitcoin as a technology with different lectures that we're going to start with. So let me give you a rundown of the different lessons that you're going to be able to see. Lecture 1, Intro to Crypto and Cryptocurrencies. So this is basically where you're going to start to know more about how the coin works, how the cryptography behind Bitcoin really actually works. Lecture number 2, how Bitcoin achieves decentralization, which is also very, very important. Lecture number 3, mechanics of Bitcoin. If you have any questions about the lessons, also I have a summary for you guys where we have bullet points where if you have an interest in any of these lectures, I can explain to you more what it is. So let's go down a little bit further. Lecture 4, this one is actually pretty important. How to use and store Bitcoins. For any of you guys first timers, This will probably be one of the most important lessons because that's the one that you're gonna learn what kind of like security, concerns you may have when you use and when you store your own Bitcoins. Because let's remember, with Bitcoin, you are being your own bank. You're basically getting rid of using the traditional banking system, and you're gonna have to learn how to use it like yourself. You're gonna have to be responsible to store your Bitcoins, and what do you have to do? What kind of steps do you have to like use to store your Bitcoins? Another one, Bitcoin mining. So we're gonna learn also how Bitcoins are produced, because that's a very common question. Okay, like how Bitcoins are made or how are created. So this lecture is going to talk a lot about like how Bitcoins are mined, so to speak. That's the term that we use in Bitcoin. And so this one's pretty good. Bitcoin and anonymity. You probably have heard like that Bitcoin is like an anonymous like currency, but we're going to define exactly how anonymous it is. Like if it's pseudo-anonymous or if it's like totally, like undercover or secret money, and what does that mean, We also have another lecture about community, politics, and regulation. This one's very important because it talks about like where the community underpinnings of Bitcoin, where did it came from. It's very, very important to know where Bitcoin was conceptualized first. It was back in 1988, as digital cash. So there's been a lot of like efforts in the past to try to create, a system just like Bitcoin. So in this lesson, we're going to study basically the history. What was going on like in the 80s, in the 90s. What were the precursors of Bitcoin? What had to happen before we came with it? It was not like a short like journey. Bitcoin was not created and then just came to be. It was a lot of like work, behind that. So we'll talk about that on this lecture. Lecture number 8, alternative mining puzzles. This one's very technical, definitely, but we will have a chance to know more about some alternatives that are being explored, so to speak. So the deeper that you get into this course, we're gonna get more technical. We're gonna look more into Bitcoin like research, or like Bitcoin technology, like what's coming up, what would be the next step, for Bitcoin. On the lecture 9, this one is actually pretty good because it's called Bitcoin as a platform. Because a lot of people don't realize that money, okay, that's how we use Bitcoin for, but Bitcoin can also be used for more than that. So we're gonna take a look at Bitcoin not only as a platform for money, but we're gonna see Bitcoin as a platform for doing more things than that. Like what's really the blockchain for, or what's the the system. We're gonna explore like different alternatives besides money, which is like really, really interesting. Okay, so the next one, lecture number 10, altcoins. You probably have heard about there's more coins than just like Bitcoin. You probably have heard of like maybe Litecoin, Dogecoin. There's a lot out there. There's probably around 600 like different currencies besides Bitcoin. So we're gonna learn, like what's going on there, what's the cryptocurrency system, like what kind of like money do they move? Do they move a lot of money? Do they move like little money? Is it like really worth like looking into as a technology, or probably not? Lecture 11, the future of Bitcoin. This is where we're gonna talk about, like what's coming up, like the evolution, like what's gonna probably the way Bitcoin is going to evolve, in the next like months actually. And then the bonus lecture, Introduction to Crypto Economics. This one's pretty good because we're going to talk about a new, different kind of like economic market, if you will. Like this is generating like a new alternative financial market, if you will, but it's completely alternative or parallel to the financial system that we've seen so far, the legacy, like financial system. So we're gonna study all of that. The courses will have a blockchain certification using the proof of system algorithm. Basically what it means is that you're gonna have a certificate, at the end of the course, if you decide to take it and go all the way with it, you're gonna have a certification. But what kind of certification is this? This is something that is fully verifiable because you use the blockchain, you use Bitcoin technology to basically put your certificate, as well. And us as an education institute, we're gonna endorse that certificate. Also, it gives you another very, very good advantage. It's permanent. Once you put it on the blockchain as a certification course, and let's say you end up with one of our certifications, it's gonna be permanent. What does that mean? If you earn the course, let's say, this year, it's gonna stay, and even like 2, 5, 10 years from now, it's still gonna be there. It's like a permanent log that you took that course. So it's a pretty good thing. So basically, Bitcoin programming certificates. That's the first part of the education project. If you're interested about learning Bitcoin, definitely check out, like this course that we have put together for you guys. It's pretty complete. We also have another set of courses. This one is actually pretty different. It's called Lex Cryptographia and Code Law. Lecture 1, Lex Cryptographia, an Intro to Software Law. What is that? Lex Cryptographia, it's basically, and I want to read something about Lex Cryptographia. In this lecture, we explore the benefits and drawbacks of this emerging decentralized technology and argue that its widespread deployment will lead to expansion of a new subset of law, which we term Lex Cryptographia. Rules administered through self-executing smart contracts and decentralized autonomous organizations. As blockchain technology becomes more widely adopted, centralized authorities such as governmental agencies and large multinational corporations could lose their ability to control and shape the activities or disparate people through existing means. As a result, there will be an increasing need to focus on how to regulate blockchain technology and how to shape the creation and deployment of these emerging decentralized organizations in ways that have yet to be explored under current legal theory. So basically, what is Lex Cryptographia? It's like an alternate set of laws, We're gonna study about smart contracts on automated transactions. Lecture 3, decentralized autonomous organizations, which is basically taking the corporations, like an LLC, and basically simulating the whole thing on the blockchain, on Bitcoin. So we have another lecture right here. This one is also pretty interesting. Societal implications of blockchain technology. This is a pretty interesting lecture. Lecture 5, smart contracts and automated transactions. Lecture 6, reducing frictions in capital markets and financing. Lecture number 7, the rise of the meter internet and the growth of the peer-to-peer economy. Lecture number 8, distributed real-time governance. Lecture number 9, algorithmic governance, breaking out from the matrix. What does that mean, breaking out from the matrix? It means basically creating an alternative subset of laws that can we can basically make our own governance. It's basically about designing a system of self-governance. At the end of the course, we'll be able to write smart contracts and be able to create decentralized autonomous organizations. So this is another course, the Lex Cryptographia. Now we're going to talk about the third education, core course. It's called the Internet of Things and Augmented Realities. In this one, we'll analyze what is the Internet of Things. What is it? It's when lots and billions of devices will be connected to the internet, and we're gonna have a mesh of devices being connected, and how we're gonna rule them, how we're gonna do governance, in all of those systems. That's the Internet of Things, So we're gonna have a lecture That is going to be the intro to the Internet of Things. The second lecture, it's called the Internet of Things Architectural Layers. In this one, as you can see, we can study, like all of the architecture layers that are coming up to take care of different applications, in environmental, people tracking, retail, supply chain, healthcare, transportation, energy, and how all the sensors that are gonna like govern and rule the Internet of Things. Lecture number 3, IoT technologies or Internet of Things technologies. At the end of this course, it's pretty cool. We're gonna build a device. We're gonna build basically like a little, a small device that is gonna be able to connect through the Arduino platform and will show the Bitcoin ticker in real time. It's basically, we're gonna be able to construct a device that is gonna connect to the internet real time, and it's gonna be able to subtract information from the internet. So it's gonna be a device that is connected to the internet 24/7, and it's retrieving, information. So this one is, part of the course. The fourth section of the education platform is artificial intelligence and machine learning. This is where it gets like really futuristic. Lecture 1, the busy child scenario, an introduction to artificial intelligence. So in this one, we're gonna take a look at the the current artificial intelligence like research, and what the research is telling us that's going on, like on current like artificial intelligence like research. Lecture 2, programs that write programs. Lecture number 3, the 4 artificial intelligence basic drives. What are going to be the main drives that is going to like rule, like this new artificial, like intelligence. Lecture number 4, the intelligence explosion. Lecture number 5, the singularitarian. That is also about like transhumanism, and you have probably heard like some of it. That one's actually pretty interesting. Lecture number 6, the last complication. I don't want to go like too deep into like these like like lectures, but I just want you to I want to give you an overview. What's the education platform? What kind of like information you're going to be able to get, from the platform. Lecture number 7, cyber warfare and Skynet. Lecture number 8, humankind 2.0 and the blockchain artilect. This is the part where we're going to talk about like the real-time like governance layer that we're trying to develop basically. So in this one, we're going to talk about like how we can break out from like government structures and be able to basically do like a real-time governance layer where you're going to be able to like break out from government like like current like structures. At the end of this course, we'll be able to interface with the most recent machine learning technologies like Google's TensorFlow and be able to teach a machine to simulate neural networks through the power of distributed computing. So basically, what I just showed you is education-based. Like all the lectures are going to be free. They're never going to cost anything, so you're going to be able to access like all of them. You're going to be able to, if you want to study Bitcoin, you're going to be able to take all of these lectures. They're all going to be free. They're all going to be able to have your, your blockchain certificate, and so you're going to have a lot of information to go through. And this is the technology section. This is where we go from education through the technology. So this is the company that I'm starting with. It's called Self-Governance Algorithms. So what is this? Basically, what I'm proposing is this. I educate people, right? So I have the education platform. If you are willing to learn everything I have on the education platform, you're gonna be able to even like work in this company. So basically what I'm doing is like taking, it's a self-reinforcing circle of education. And if you're willing to learn and really, really, really learn, you're gonna be able to jump from that to the technology section that we're gonna start to construct, like these days. And we're gonna be able to even like offer you a job, like, which is like really, really good. So education, and this is technology. And I think I went back a little, so let me go. I think it went down. So let me get back to the technology initiative. So far, we talked about education, So I gave you like, the rundown. We have Bitcoin, we have artificial intelligence, we have Lex Cryptographia, which is like software law, it's like code law, it's like taking away that. And we're now going to talk about technology. Okay, so what is this? We're taking, the Internet of Things, which is the stuff I just talked about, and we're going to take, artificial intelligence, machine learning. We're going to take distributed computing, which is really, really, really powerful. We're going to take a new service called Blockchain as a Service, BaaS. That's the new thing that the banks are actually like getting into, the BaaS. And we're gonna take, of course, software law and Lex Cryptographia, which is the stuff I was like telling you before. And we're gonna come with, this architectural layer. This is the technology section. And I have to really admit, this is still very theoretical, like this is the technology section. A lot of the technology that is needed here, especially when it comes to like the algorithms and the machine learning, the negotiating layer, they haven't even been invented yet, So I have to really admit, this is a very theoretical exercise, This is where my vision is, and that's why I want to invite you, I want you to like dream with me, if you like, like about education. And if you want to get free education, and after that, even like, probably get a chance to like work, with me, you're gonna have the chance, So this is like, the presentation. But what is the Blockchain Artilect? Because that's what I have for you today. Blockchain Artilect, the creation of the world's first censorship-proof, government-free, decentralized self-governance platform. That's the gist, It is crypto anarchy embodied, a futuristic, complete system of code law based in global self-governance consensus algorithms and artificial intelligence. I know it sounds very futuristic, right? Blockchain Artilect, it is the embodiment and natural evolution of Lex Cryptographia, which is the term I was like talking about earlier. Blockchain Artilect, a globally fair, real-time governance political system. And this is what I want you guys to dream with me for a bit, because here's what I want to say. For thousands of years, we have heard pharaohs, kings, and priests, and governors, and politicians, and congressmen, and even county commissioners, telling us what to do, like what the set of laws should be. This is the time that I want the 99% to actually talk back. We like stop listening, and now we can do the talking, because we have the real power. We are the 99%, and with Ethereum and what I'm about to present to you in just like in the next few slides, I'm pretty sure that we have a really, really good opportunity to create something like this. So, Blockchain Artilect, social operating system for planet Earth. I know it sounds very futuristic. I want you guys to dream with me. I'm starting with the education platform. It's free. It's totally open for you guys to check it out. And I'm a Houston local, and I head the education initiative, and that's what I want to like give you like today. This is like the first part of the the presentation. Education, technology. And I hope I was like pretty clear. Now we have a Q&A, so I want to make like a little pause between like all the the teams or the parts of the presentation. So far, any questions? We talk about education, we talk about technology, we talk about the Blockchain Artilect. Is there any questions so far? There you go.
You might, I might have missed this,
Yeah.
but some of the lessons that you were showing
Yeah.
are those live online already?
Yes, yes, they're all like online.
Where can we go to find them?
IamBitcoin.org, and it's also on the presentation, and probably the second or third slide. It's the
I think you
IamBitcoin.org.
said that already, but thank you
Oh,
for
perfect. No, it's
helping
good to
me.
know. Like also for the presentation, IamBitcoin.org. So let's any other questions so far? So education, technology. I think we're pretty good on that. All right. So let's move on to the state of Bitcoin 2016. So in here, I want to give you a at a glance what's going on. Like what's the current state of the Bitcoin network. So first we have, of course, the price per Bitcoin as of this morning, $392. What's the market cap? That means what's the network like valued, like at. It's almost 6 billion as of this morning. The difficulty, big number, I'm not even going to say it. Hash rate, also a big number. We're actually going to have a slide after that because that's a staggering number. This is giga hashes, and this is also like a big number. And the average block size also, it's a very important metric that we also have to, like keep in mind on the Bitcoin network. That's why I'm gonna put it in here, because we're gonna talk a little bit about it later, So here's what I wanna say. Welcome to the era of the hexahash. What does that mean, like the hexahash? What it means is that the hash rate, or the rate of what the Bitcoin network is doing, all the calculations, you're probably familiar with miners and what they do. It's a process called hashing, which is a process of just like trying to find like a number. It's like a lottery, basically. So the rate that the whole Bitcoin network is hashing today is a 10 with 18 zeros after it. So it's like a staggering number. That's why I say welcome to the era of the exahash, because here's the thing, guys. We have never in the history of humanity had something that would work in these rates, like exahash. Not even a supercomputer, which is the world's most powerful computer, is the TNN-3, and that's in Japan, and is used for like weather, like modeling, and costs like millions of dollars. That thing works at 25 teraflops, and this thing is working at 1,000 teraflops. So you think 1,000, and the world's fastest supercomputer, it's 25. So that means Bitcoin is operating on a level that is way past any supercomputer. Like it's about 3,000 times faster. What does that mean? Exahash, like I said, equals to 10 with 18 zeros hashes per second, or 1 quintillion operations per second. So that's the rate, 1 quintillion of those little hashes, per second. Just to put that number into perspective, that equals to every human on Earth to have on average of 135 million hashes per second, just to match that. That's what we would like, every human on Earth would have to do just to match that rate. So it's like a staggering number. What does that mean? That means that the current state of the Bitcoin network is very secure, because the hashes are used to secure the network, if you will. That means that all of the work that the Bitcoin network is doing, any attacker, we have to redo it. So in order to match that kind of computing power, like we don't know in anything that would probably match that, So in order to redo, like that distributing or computing power, that's why this distributed computing is so powerful, and that's why Bitcoin is so powerful.
Just a question. So that means that it's impossible to have a hacker on Bitcoin?
to have a, I mean, there's theoretical ways to like attack Bitcoin, but the theoretical side, it would take, theoretically, yes, there's ways that you can probably like do something that you should not do, but it would just take so much power in computing that it would not be even economically viable. So you would have to spend, you would have to have the budget of a nation state in order to kind of like attack Bitcoin. You would have to spend so much power and so much like computing that, in order to do something malicious. So that's why, it's so important to keep track of the hash rate, because that's what keeps the network secure. More miners or more people doing it equals the network more secure. I hope that that's pretty clear. So what's the problem with the Bitcoin network? We're gonna analyze like the two main issues at hand that are going on in Bitcoin. The two main issues at hand is the lack of a consensus mechanism. What does that mean? In one of the lectures that I talked to you guys about in the first section, we analyzed who really controls Bitcoin. And then we're gonna realize that the control in Bitcoin is very distributed. Like us, as users have some degree of power if you use like, like the network. Miners also have like some power. Merchants, the ones that process, Bitcoin transactions. Let's say if I go to, buy an airplane ticket, payment merchant is going to process my Bitcoin, like payments. So they're really important, So there's not a consensus mechanism that is implied, like in Bitcoin. Let's say we want to make a change in the Bitcoin protocol, let's say the Bitcoin code, so to speak. What's going to be the consensus mechanism to make that happen? Like it's really not implied, Even the creator, like say that, okay, the consensus has to work, on percentages, basically, like to take over, like the consensus. And also, here's the problem. We have an artificial block size limit of 1 megabyte, but what's a block, or what's the block size? Blocks are basically all transactions that happens on Bitcoin over time. You get added as a block. Let's say, I do a Bitcoin transaction right now, and that stays, in the Bitcoin network recorded, is gonna go into a block. Like a block is kind of like a page in a journal, if you want to do like a little analogy. So if you want to think of the blockchain like a ledger, so to speak, like, like just a block would be a page. So we have like a artificial, like a page size, so to speak, so we have only so much that we can write, on that page. So we're still trying to figure out, okay, do we increment that page to like double the size, triple the size, maybe 10 times the size? I mean, that's a big question, like how do we do it? So like these two things, they combine together. We don't have a consensus mechanism that is implied, and we have this, which is, the page limit or the block size limit. How do we get past that, So these are the possible solutions that are being like studied right now in Bitcoin. One of them, it's been pretty popular in the last couple of months, segregated witness. So we're gonna, talk about what that is. It's pretty technical, but I'm gonna try to give you a rundown of, like what it is, how it works, and if it's a good solution, or, like what's the implementation of that. Also, you have probably heard about the differences, something called Bitcoin Classic that has been going on in the Bitcoin circles, Bitcoin XT, that's also like another flavor of Bitcoin, if you will, and you have Bitcoin Core, So now you have, at least here, you have like 3 competing like visions, of like what Bitcoin should be. So we're gonna analyze, exactly what the main differences in those proposals are. And also we're gonna, this one is pretty cool because we're gonna put a video actually, and we're gonna see how flexible like Bitcoin is. I'm gonna put a video, and then you're gonna see all the changes that have been done to Bitcoin in 2015, you know, which is like last year. And you're gonna see that Bitcoin is not like a static thing, you know, like we don't have like the code and it just stays there and nobody like touches it. The code is actually something that is always like on the move. And the video that I'm gonna put to you guys is gonna show you graphically, you know, like how does the Bitcoin protocol like moves, you know, how flexible it is. So another proposal, Lightning Networks, that's also about scaling Bitcoin and to make it like truly kind of like worldwide. You know, how do we scale Bitcoin from being just a little niche right now where we have like maybe 100,000 users right now? How do we scale from 100,000 to like planetary scale? You know, we're talking about billions, you know, like if you want to take Bitcoin to take over the world, you're going to have to do like some changes. So Lightning Networks, it's a promise to probably reach that level, you know? So segregated witness, what is it? This is a brief like summary of how Bitcoin transaction works. You know, like this is a very simple diagram. So the way they work is that they work by inputs, and these inputs, they actually belong in something called the UTSO set, you know, which is like the Bitcoins that have not been spent. And that's why you're able to spend that Bitcoin, you know, because you own that signature. And then you create, you know, this other signature, which is basically the transaction. But what is segregated witness? Segregated witness is about looking at Bitcoin transactions, basically, and just realizing that the signatures on this side, which are basically like the receipt. Let's say I make a Bitcoin transaction with you. I'm going to show like a signature that shows that I own those Bitcoin. It's kind of like a receipt, if you will. Segregated witness is about, okay, we need the receipt at the moment of the transaction, but after the transaction has been completed, we don't actually need the receipt. You know, like the transaction was valid, and that's all we care about, basically. So that's kind of like segregated witness. That's a very, you know, like a brief summary. So we talk about digital signatures, which are the receipts, you know, that I just talked to you about, only needed for fully validating nodes, and are only needed for the time of validation. That's really, really important. That means those receipts, they're only needed when it happens, and after it goes on the blockchain, which is like this ledger, they're really not needed. So that's what segregated witness is all about. Do not even enter the UTSO set, so no long-term resource like costs. They occupy 60% of the blockchain, which is basically this big ledger that we have, you know. So we come to realize that digital signatures are basically not that much needed. You know, we can do something a little bit more sophisticated than that. And so it's about ignoring them where possible. So this is just one solution that I want to present to you guys, and just so you know what's going on in the Bitcoin, you know, like network or the Bitcoin community right now. Here's where does the term witness come from? I mean, like, what is it called witness? It refers basically to the inputs. That's basically when you are about to perform the transaction, not part of a transaction effect, only proving it was authorized. So you can call a witness just like a set of eyes that saw the transaction happening, and they say, okay, I was a witness of that. In cryptography, we call that, it's a crypto primitive actually called a witness. So basically that's the implementation. You know, it's like a mathematical implementation of something called a witness. And that's where the whole name comes from. So that's why I wanted to give you like a little rundown of, you know, where the name like witness comes from. The current set of implementation is we have a testnet. What is a testnet? When you want to make a change to Bitcoin, you just don't go ahead and put it, you know, like on the mainnet, it's called. But they usually put it on something called a testnet where we can run simulations, if you will. So right now we're running the, you know, the segregated witness on a testnet. That means it's like simulating real world situation. It's simulating real world transactions, you know. So we're gonna know what kind of effects we're gonna have, because we don't wanna like, you know, just launch it and let's hope it's fine, you know? We don't wanna do that. And I wanna give a brief warning. The actual code, it's 500 lines of code. And just to give you an idea, and it's something that has never been done in Bitcoin before, that amount of changes. And that's why I believe the current testnet is very, very important, because there's two different schools of thought. Some people think it's like a really easy implementation, but when you look at the actual code, you tend to realize that it's probably not so simple in terms of you know, programming. So it's very good to have a testnet like going on. So I wanted to give you also like both sides of the coin, you know. Okay, so here we go. Bitcoin Classic versus XT versus Core. Where are they? Okay, so basically, I don't know if anybody here is familiar with Linux. You know, like you probably heard of Linux, which is like open source basically as an operating system. So in Linux, you also have flavors of Linux. You have like, you know, Ubuntu, you have Debian, you have Raspbian, you have like all kinds of flavors. That is the spirit of open source, basically, that everybody can contribute, you know, to open source like software. But what's going on right now? Now we have diverging views of where to go. And honestly, in the long run, I think it's good, because this is the spirit of open source. You know, that's how Linux has been developed. And I believe that Bitcoin it's also the spirit of open source, you know, like software that everybody can see what it does. And they just have different visions, you know. What is Classic Vision, for example? Okay, Classic Vision, they want to just make a very simple change. Just increase the 1 megabyte that I told you guys about and just increase it to 2. That's it. Like no more changes. That's Bitcoin Classic, you know. Bitcoin XT, it has lost a lot of support in the last couple of months, I would say, to the point where it's like really no longer like very relevant, you know, because it was very complicated at one point, and then it just lost a lot of support. So Bitcoin XT, you know, maybe like something that is not very like current, but it's worth mentioning, you know, because that's another kind of like the competing like visions that we have for Bitcoin in the past, like maybe 2 or 3 months. Bitcoin Core, that one's really important because that is the most like senior. That's the one that's been maintaining the Bitcoin software for the past 6 years. So basically this is the original, you know, like Bitcoin Core. Those are the guys, the developers, which are around 47, that worldwide they contribute to the Bitcoin, you know, like code. So Bitcoin Core also has its own you know, like roadmap, or like where to take Bitcoin. Bitcoin Core believes in segregated witness, which is the one I showed you about, and Lightning Network. So that's like the Bitcoin Core, you know, like opinion, so to speak. So on the next slide, I'm gonna show you the video. So on that one, you're gonna be able to see how flexible and how much Bitcoin changes. So here we go. So here you're gonna see 1,129 commits. See if I can turn down the volume, but it's fine. Okay, so basically what you're gonna see on screen is like all of the little dots that you see, those are the main contributors. Those are like people right here. And those are the changes being made to Bitcoin. With the timeline that you see all the way on the top, you're gonna see we're up to like February, and then you see milestones in there. That means when the software was released, you know, like new versions of the code. So you're gonna see like how does it change over time. You're gonna see that Bitcoin is really not static, as you can see. So you're going to be able to see how it changes and how like all the network is basically getting more complete, you know, if you will. We're up to like April right now, and we see another milestone coming up. we're gonna see all the releases, you know, of the Bitcoin protocol. You see another milestone right there, April 27, and you see the timeline also going on. We're up to June. And you see all these people going from this place, going to work on that and here, and then you're gonna see they work on many different aspects, you know, Bitcoin. You're gonna see like no single contributor just stays, you know, in one area. So you're gonna see them always contributing to different parts of, you know, what the Bitcoin network is. So I just wanted to give you like a visual representation that really Bitcoin is a very, very flexible thing. You know, as you can see, it's always evolving. That's what I mean. We're up to last September right now. And you're gonna see all the changes that were done. Basically like a time lapse. And I think that's enough because for now, like it was just like a couple of months before it finished, you know, in December. But I think that will give you a very good idea of, you know, how Bitcoin changes in just 1 year, guys. It was 1,929 commits. What's a commit? A commit is basically like a change, you know, on the core like protocols. It was almost 2,000 different like small changes or additions to the Bitcoin network or the core protocol. So it's very flexible. Like I mentioned before, you know, the Bitcoin, the core, you know, the roadmap, you know, which is the most senior the group so far. They have this segregated witness testnet, and they have also the possible implementation of the level 1 of the Lightning Network. Well, what is the Lightning Network? Let's talk about it. Lightning Network, they are basically the creation of payment channels, if you will. But what's the main advantage of having those payment channels on Bitcoin? The advantage of it is that you don't have to rely on the blockchain, which is the main ledger, you know, with Lightning networks, but basically it's going to happen. You can do your transactions off the main like blockchain or off the main ledger using these payment channels, and you can do those in a very fast and scalable way. The Lightning Networks has 3 levels of implementation, and basically we're going to start with level 1 this year. Level 2 and level 3, they're probably going to implement it, okay, like much later. But level 3 allows up to like 250 million users of Bitcoin with up to like billions of transactions, you know, like that's truly on a global scale. So Lightning Networks, what it is, it's basically taking like Bitcoin and make it like way, way more scalable, you know, because right now we have an actual limitation, you know, like we have an actual limitation of about 3 transactions per second. And just to give you an idea, PayPal process around, what's PayPal at, like maybe 20, probably more, but Visa and MasterCard, they're in like probably 10,000 transactions per second. So we still have a lot of, you know, like of room to grow to actually match, you know, like a payment network like that. And the Lightning Network is just like one way that we can, you know, like reach that. So this is like the final of the second part. Any questions so far? We talk about the state of Bitcoin. We talk about the code. We talk about, you know, different competing like visions for Bitcoin. We talk about Bitcoin XT, Bitcoin Classic, Bitcoin Core. Any questions so far?
That video you showed,
yeah.
I didn't quite understand what all that was going on.
Oh, okay. Well, in that video, what happened is that you are going to see the changes basically made to the Bitcoin, like the core protocol, like the software that basically like governs like Bitcoin. Yeah. What we saw in that video was a set of like contributors, if you will. There's about 47 different like persons, you know, that I can name a few, you know, like Gavin Anderson, like Peter Todd. So basically what you saw in the video was these guys, you know, like Gavin Anderson, just doing a change, like one part of like the protocol, and those were like those dots that you see there, like part of the network, and how Bitcoin actually just in 1 year, it has changed, like so much and evolved, basically to become more robust, if you will. So it was just, about the evolution of the protocol. Any other questions so far? Yeah.
What it means is that Bitcoin is decentralized of any kind of government?
It is what?
Decentralized, not centralized on any kind of government.
Yes, Bitcoin by nature is decentralized. What does that mean? That means that Bitcoin core, even though, they do all those changes and, they have the oldest group, they don't have full control over Bitcoin, If they want to make a change that most, like the community do not agree with, people can actually change and start to use Classic, for example, like using like a Bitcoin Classic node or using like a Bitcoin XT node. I mean, that's the essence of open source. Bitcoin Core is the most respected so far. I would probably like trust a lot of like the Bitcoin Core developers on that group. But of course, Bitcoin Classic has some big support as well. I mean, it has like some big supporters. So it's something to, like worth like listening to, like what's Bitcoin Classic and what's Bitcoin XT and all that. So any other questions?
The guy that recently left that made a whole commotion about leaving his programming position or whatever. What was his beef related to something like this about the governance and how people can't get anything done, decisions and all that?
Yeah, that's a good question actually. So the question was about the recent article declaring like Bitcoin dead, I guess, and that's a very good question because like Mike Hearn was also part of like, like what we just saw, like a Bitcoin core developer, and a big supporter of XT. And basically, like what happened is that Mike Hearn, as a developer, just basically got like fed up, with the lack of like the consensus, like because like I showed you before, there's not an implied consensus, like algorithm in Bitcoin. So I would say, for a moment, the Bitcoin price like went down, and that's why I wanted to give you the state of the Bitcoin network in the beginning, because you see the price at $392 as of today. For me, it's far from that, like Bitcoin and the exahash, like network, the way the health of the network has never been better. That's what I want to like probably summarize that when it comes to like those rumors, that Bitcoin is like dead or, it's not gonna get anywhere. I mean, it's a very healthy network. Any other question, Bitcoin and all that? We're gonna get into Ethereum. So I guess we're gonna like get into that. So this is the last part, okay? So Ethereum, a mathematical introduction. Okay, so this is my idea. Ethereum is very abstract, Ethereum, it's something that it's, in my own opinion, it's a beautiful mathematical like construction, if you will. And for me, the best way to introduce you to Ethereum from a very fundamental level is to show you the equations, basically, like just the math, just hold on tight. We're gonna show you some equations in the next couple slides. So it's gonna be math-based, basically. And don't worry if like you don't get, like any of it, like most of us are not like mathematicians or like programmers. But I wanted to give you an introduction to the mathematical fundamentals of Ethereum so we can go from there. And remember, you're gonna have the PDF as well. So make sure, even if you don't get some of it like right now, you're gonna have the chance to, check it back later and see like what's going on, So Ethereum, taken as a whole, can be viewed as a transaction-based state machine. What does that mean? It's just like a big computer that it's transaction-based. What does that mean? That it just works on transactions. Like you have a computer, but you're not going to interact with it just like using like commands, like we're used to. It's going to work on transactions. So that's the beginning. The state. What does the state mean? it can include such information as basically anything: account balances, reputations, trust arrangements, and data pertaining to information of the physical world. What does that mean? You know, like in Bitcoin, you know, all you can have is just like money, basically balances, you know, like that's your Bitcoin balance. On Ethereum, you can basically have as your balance, you can have anything. You can have a reputation, you can have a trust arrangement, you can have basically a financial derivative. It's fine. It works fine on Bitcoin. You want to have something more sophisticated than just money, and Bitcoin will process it. Ethereum will process that information. That's a state-based transaction machine. Okay, but let's see, what does that mean? We're going to talk about the Ethereum, the blockchain paradigm. So I'm going to hit you with the equation right now. So don't be scared. Okay, like this is the equation. Okay, so this is the equation that is called the Ethereum state transition function. Okay, so we're going to try to analyze the elements. I'm going to try to explain to you what those symbols like mean. So we have that symbol, but it's called epsilon. Epsilon is basically the Ethereum state transition function. But what is that? You know, what is like this symbol right there? It allows components to carry out arbitrary computation. Still, what is that? You know? Okay, what can you have on an arbitrary computation? You can have contracts, which is really, really important. Like contracts are basically the programming of our society, you know, if you will. So you can have contracts, account balances, software programs, cloud computing, anything that can be computed can be processed by this function. So that's really, really powerful. What does that mean? If you throw a computation into this, it will basically process it. Like, just it's Turing complete. So anything that you want to throw at it, you know, that it could be modeled mathematically, this function will say, okay, I'm gonna handle it. I'm gonna process it. And then you have sigma. What is sigma right here? Allows components to store arbitrary state between transactions. So you have these two, sigma and epsilon. So the way it reads is like sigma under t plus 1 is equivalent to epsilon parenthesis sigma under t comma t parenthesis. That's the whole equation. These two are the most important components of Ethereum. So you have the sigma and you have the epsilon. You have a What's the what?
The big T.
Oh, the big T, transactions. Yeah. I'm sorry about that. Yeah, like so the big T, I should like probably, you know, like do the whole thing. So yeah, it's transactions as well. And so you have the main equation that governs, you know, like Ethereum. But what could it do without the blockchain? You know, like this actually on theory, it's amazing, you know, because you can throw anything that you want at this basically, and you can store anything you want in here. So you have storage and you have processing. So that's basically what makes a computer, right? You have storage and processing. But where's the blockchain? So that's these are the last three equations, just so you know. I mean, I'm not going to be putting like equations all night. So what is this? We actually span from the equation number 1 that I just showed you. You have number 2, 3, and 4. What is this? This is where you have the blockchain, basically, like integrated with Ethereum. And that's basically the end of it. 4 equations, you have one of the most powerful computing projects ever. What is pi? That's a block level state transition function. That's basically the one that makes the blockchain, you know, like work. The one that, you know, pi is the transition functions for every block, you know, for every page that we turn on Ethereum. That's the one that does the transition function. But that's the one that interacts with the blockchain, if you will. So you have the equation number 1, Ethereum. Equation number 2, That's where we get into the blockchain. That's where we unite those two, if you will. The current block also, which is B, which includes a series of transactions amongst other components. We should understand B because that's the one we've been talking about. That's a block, that's a page of the ledger, basically. And finally, we have, delta, which is the block finalization state transition function, which is a function that rewards a nominated party. This is the one that pays. This is the one where like Ether are actually produced, this is the one that rewards to anybody that's mining. That is called incentive like engineering, that's the one that rewards anybody, any miner that will be like contributing to the Ethereum network and any kind of blockchain. That includes Bitcoin as well. That's a function that rewards a nominated party. That's the one that gives you Bitcoin or gives you Ethereum in this case every time a block is mined. So that's basically the blockchain, just like 3 equations. So, okay, so we're gonna talk a lot, like the final characteristics of Ethereum. The Ethereum virtual machine is a simple stack-based architecture. The word size of the machine and thus size of the stack item is 256-bit. If you're not a programmer, you're probably not gonna like understand, but that's basically the language that Ethereum like talks. It's a stack-based architecture, and the word size, which is basically like the computation that it works on, it's on 256-bit. I mean, it's just very, very, very easy, I guess, to understand if you get into architecture of systems. The memory model is a simple word address byte array. The stack has a maximum size of 1024. All locations in both storage and memory are well defined initially as 0. What does that mean? That we start with the blockchain of when Ethereum was launched back in 2015, which was August. The state transition that it worked with, it was defined as 0. Basically, it had no balances of anybody, no accounts, no reputation. I mean, that's how blockchains actually start. So that's a definition of Ethereum. That's what it means. Basically, how Ethereum is defined. That everything is defined as 0, and then you build on that. That's the blockchain. Everything is defined initially as 0. When Bitcoin was launched, there was like 0 coins. When Ethereum was launched, it was like 0 like coins. Unless you're pre-mined. But in order to avoid issues of network abuse and to sidestep the inevitable questions stemming from Turing completeness, all programmable computation in Ethereum is subject to fees. What does that mean? That if you want to use Ethereum as a computer, let's say, you're, okay, I love Ethereum, let's give it a try. Any computation that you want to perform, it's subject to fees. Let's say it's not free, so to speak. That's basically what it means. Ethereum is a fee-based computation architecture, just so we're like clear. It's like a fee-based. So you want to do a computation on Ethereum, you pay something called gas. Let's expand on that. The fee schedule is specified in units of gas. So that's how it's called. What is gas? Basically, gas is just like fueling your computation. Let's say, you have like a cloud computing like a project. You want to hire like computers to do tons of stuff. You have like a servers and all that. You can tell Ethereum to do that, or you're gonna have to pay the machine in units of gas. That's what you burn, basically. And if you don't have enough gas, the machine is basically gonna literally run out of gas, and it's gonna return to the initial state. It's like basically wanting to use a car, and if you wanna use a car, you better like put fuel on it, so otherwise it's not gonna take you wherever you wanna go. Let's say you wanna travel, all the way across the country, you better put a lot of gas in your car. So that's basically, the analogy. All the fee schedule is specified in gas. Thus, any given fragment of programmable computation, this includes creating contracts, making message calls, utilizing and accessing account storage, and executing operations on the virtual machine has a universally agreed cost in terms of gas. So what does that mean? That means that everything is universally agreed. Like on the network, actually, if you go to the Ethereum, it's called ETH-DEV-STATS. It's going to show you the actual, the universal agreed in terms of gas of what a computation should cost. It's kind of like having the oil price, that it's been like all over the news lately, and everybody knows what the oil price is these days. So on Ethereum, you have also a universally agreed, like amount of what the gas it's going to cost. So nobody's going to pay more than that, but nobody's also going to pay less. It's like a universally agreed, like a gas computation. And then this is actually pretty remarkable. The machine does not follow the standard von Neumann architecture. What is the von Neumann architecture? That is pretty remarkable because the von Neumann architecture is basically what all the computers that we know to this day are based on. The von Neumann is basically on the input and output. Even supercomputers are made in such a way that, of course, you use a keyboard, or a way to input information, and you have an output. You have a monitor, and you have some kind of way of displaying that result. This machine, the Ethereum, does not follow that architecture. What does that mean? That in terms of like storage, for example, like a supercomputer, you can always think of like a big, like a room, like full of like storage, with like full of disk and all of that. Ethereum does not follow that. It's actually the world's first zero infrastructure like network, because all of this storage is not physically like on. I know what it gets like really abstract, but it's like everywhere and nowhere at the same time, because all of this storage is based on the sigma function that I showed you before. Remember on the first equation, that little sigma, the one that allows you to store. Well, here's the thing: Ethereum does not follow the regular storage, like architecture that we're used to. It's a different architecture. The machine can have exceptional execution for several reasons, including stack underflows and invalid instructions. Like the auto-gas exemption, they do not leave the state changes intact. That's when like the analogy I show you when you get on a car and you just like simply run out of gas. It's not going to leave you in the middle of the road. What Ethereum is going to take is like, okay, you run out of gas, we're going to take you just like way back to where you started, because you don't have enough gas to take you to all the way. So this is what it does. The machine halts immediately and reports the issue to the execution agent, So that's exactly how it works. I've been trying to put analogies so you guys can understand kind of like, because Ethereum is actually like very, very abstract, especially because of the fact that it does not follow the standard von Neumann architecture. Like it's not the standard like computer that you see with a hard disk and a monitor and a keyboard. It's really not like that. It's like a global computer, where you can store like functions and everything that you can model mathematically. Ethereum will process it. It's just like a global virtual machine. Like that's how I would describe it. So basically, this is what I wanted to show you guys. The way I think about Ethereum, it's a beautiful mathematical construction. The way I see Ethereum is like as beautiful as the way I put it is like the Sistine Chapel over time, because for me, honestly, when Ethereum was being built and launched, I thought it was going to be like one of the most like historical like moments. I was actually very, very excited, when Ethereum was launched. Just because I really, really believe in this. Ethereum is a beautiful mathematical construction that I consider the Sistine Chapel of our time. Being about numbers, this was my personal idea of an introduction to it. So I hope you guys liked it. We have a few links about articles that I published before about the blockchain. It's called the Black Swan blockchain theory that you can find on this link. And also a visual story that I made about privacy and freedom in the cyberspace. So that's also like some links that you would probably like to check and read if you want to expand about what the blockchain is and all that. So this is what I have for you guys. Thank you very much. And yes, we have the Q&A. Thank you very much. We have a Q&A. Yeah.
The Bitcoins, I really don't know anything about it.
Yeah.
I'm kind of curious about it. Now, you're saying that there's no storage, so it's just a process, right? So once a transaction is processed, there's no record or anything of it?
Well, I don't want to confuse you because part 3 was the Ethereum, which is different from Bitcoin.
It's a type of, Ethereum is a type of blockchain.
It's like a type of, exactly, it's like a type of system that is very similar to Bitcoin. You can think of Bitcoin like similar to digital cash, and you can see Ethereum like the digital equivalent of like financial derivatives, like something more like a little more like abstract, but you can see Bitcoin as just cash. To answer your question, the transactions stay. Actually, Bitcoin is not totally anonymous. They are pseudo-anonymous. What does that mean? That if you do a transaction on Bitcoin, it will stay there, like actually literally forever. But it's gonna only associate your identity with just numbers. It's just a bunch of numbers that moved around, but there's absolutely nothing on the network that is gonna have your name associated with it. So
But
that's
it's still storing that number.
they're still stored because that's how we keep track of all the Bitcoins that have ever existed and will ever exist is in that ledger. So that means when you send $10 to your cousin in Oregon, that transaction is going to stay on that ledger forever, but neither of you and your cousin are going to have their names on that ledger, just like a bunch of numbers, But what you want is send the money. So basically, that's the value of the network. I hope that.
It's not going to be names, addresses, countries, nothing about.
There's no entry barriers for Bitcoin, so that means anybody with legacy software can use it. You can download the Bitcoin wallet to your cell phone right now. So there's absolutely no entry barriers to Bitcoin. That means you can download it. It's not like when you go to a bank and they ask you, 10,000 questions to open a bank account. Bitcoin is going to represent the inclusion of the rest of the world population in the financial system. So that's also pretty cool. That even people in Africa can use it. People in Afghanistan can use it. I know an initiative in Afghanistan where a woman there, they started to produce goods like knitting and stuff, but they're not allowed to have bank accounts in Afghanistan by law. So they started to use Bitcoin to get their remuneration for their work, so they got around the banking system and said okay, I want to work, I want to keep my money.
What backs Bitcoin?
Say what?
What backs Bitcoin? Our currency is backed by gold.
Our currency is not backed by gold.
Well, I mean,
It's backed by the fate of it's called fiat. But here's the thing, Bitcoin is backed by, all that network that I told you, the hashes. Remember the staggering number that had 18 zeros after that? Basically, what it means is that the network is confirming all of the transactions so hard and so fast that you can just basically trust the network so much because all of the miners or all of those calculations are made such that the network is working in the way it's supposed to. So it's not backed by gold, it's backed by computing power. That's how
it's backed by the faith in the transaction processing mechanism.
I would say that as well. It's that's what it's based off.
It's a very fault tolerant system. So you have 1,600 people around the globe that are processing these transactions at any one time. If one person goes down, say if there was a bank that equivalent to the real world, if a bank goes down, you can't get your money out of that bank. That can't happen with the Bitcoin network.
Okay. So we're gonna end the presentation, but we're gonna network. So any other questions? So thank you a lot for being here. So okay, thank you everybody.